Hey guys, HackerSploit here, back again with another video. Welcome back to the Adversary Emulation series, where we'll be exploring the process of emulating and or simulating the tradecraft and TTPs of real-world threat actors and APT groups. In this video, we're going to be focusing on FIN6. FIN6 is a financially motivated threat actor known for its sophisticated tactics, and our primary objective in this video is to emulate, to begin with, the initial access techniques that we essentially outlined in the emulation plan in the previous video. So if you're getting to this video without watching, or if this is your first time watching one of the adversary emulation videos, I would highly recommend you take a look at the previous video where we sort of outlined the emulation plan. But the objective here is to focus primarily on initial access via a spear-phishing attachment. So it's not really important that we have, we're not going to be focusing primarily on the actual delivery of the document and stuff like this. I'll speak on some of the other techniques that we can sort of adapt, or some of the TTPs we can adapt as we proceed. But the objective here, as I said, is to emulate initial access via spear-phishing attachment. So we're primarily going to focus on the fundamentals to get things going, and then as we progress, even in the next video, I'll probably make a video on how to develop your own VBA macros, or how to develop your spear-phishing documents, let's say, from scratch. So once we achieve initial access, we're going to move into local privilege escalation, and I'll sort of explain, if you've gone through the lab that I mentioned in the previous video, you may not have seen a section on local privilege escalation, but that's what I'll be walking through as well. And all of this will set the stage for the next phase of FIN6 emulation, which will be Active Directory enumeration, and then we'll cover Active Directory or directory privilege escalation in another video, and then finally we'll have a final video which will be exfiltration. So I'm covering each of the phases or each section of the attack lifecycle in its own video to, again, make these shorter and much easier to consume. So just to reiterate one more time, for the purpose of this video, we'll be following the emulation plan, and we'll automate the development of the macro-enabled document with Metasploit. However, in the next video, so the video after this one, I'll pretty much cover the process of how to develop your own VBA macros for initial access. So for any of you who are wondering whether I was going to cover this in detail, I will. The idea is to, firstly get you going, and then we can explore some of these techniques or sub-techniques in greater detail, which is, exactly my goal. So don't worry if that was one of the things you're looking forward to. We will get to that, and then once we've covered that, we'll then move on to the Active Directory side of things. So before we get started, I just want to revisit the emulation plan. So link to this will be in the description section. We outlined it in the previous video, but on the Center for Threat Informed Defense Adversary Emulation Library GitHub repo, you can see I'm currently in the FIN6 folder. And this is the emulation plan that we'll be utilizing, or the lab on CyberRanges utilizes, I should say. And we are primarily interested in phase 1, and this is what we're emulating to begin with. So this plan really doesn't focus on initial access, but just outlines the two primary initial access vectors, or techniques, if you will, that FIN6 has been known to use. And if we take a look at the TTPs on the attack navigator, you can see that their primary initial access techniques revolve around valid accounts. But these also, come in handy, or have come in handy for FIN6 when performing lateral movement. But you can see their primary ones are, utilizing a spear-phishing attachment, etc. Given that we'll also be, once we have gained initial access, we're essentially, in the realm of execution, or whenever we enter or type in a command, that's considered execution, we need to also understand what command and scripting interpreter FIN6 has been known to use. Now, FIN6, given the choice of tools, has utilized Cobalt Strike, Metasploit, Meterpreter, but primarily they utilize, the Windows command shell, although not that much. But I think, if you have to look at it, or if you have to analyze a lot of their campaigns, you can see there's a lot of use of PowerShell. So we'll also be doing that or facilitating that through Meterpreter. So hopefully that makes sense. Now, again, if this is your first time watching this series, we are going through these, these emulation videos, if you will, or these emulation exercises using a set of pre-built labs that are, absolutely free to access, that I actually built. These, of course, were based on an adversary emulation labs that were posted on GitHub by the Might Ingenuity team. Again, reference or info on that is in the previous video. In any case, I'm not going to waste more time. A link to the playlist on CyberRanges is in the description section, and we're going to be utilizing Lab 1.3. If you're new to CyberRanges, again, you can just visit app.cyberranges.com. Registering for an account is free. Again, link will be in the description. You can head over to the community section once you've created your account and you want to look for this playlist of labs here. It's the MITRE Attack Defender Adversary Emulation Fundamentals playlist. We already went through lab 1.1 in the previous video, so now it's 1.3. And I'm just going to go ahead and start it. I believe I had my lab already good to go. This lab pretty much has whatever we are going to be covering documented. So, pretty much whatever commands or the phases that we'll go through. However, as I said, there's going to be a slight deviation because within the lab documentation, it highlights, when you're sort of emulating or simulating a victim, downloading and opening the document, you can see that the official documentation tells you to run Word as administrator, which we're not going to do because in the case of this lab or, this specific walkthrough or documentation skips local privilege escalation, which I think is not that realistic. So I'm actually going to include that in my demo. In any case, you have the walkthrough here in the overview. So you can always refer back to this. And if you want to access any of the systems, we have a Kali Linux system that's, good to go. This is the IP within the lab environment. You can access it in your browser via RDP. These are the credentials for the Kali Linux system. And then for the domain controller here that's running, I think, Windows Server 2016 or something, or 2019 it could be, although we'll have to find out. You can see the credentials here. So these can both be accessed, directly in your browser without any issues. So when you open it up, you'll have the Guacamole dashboard where you can then open up your Kali Linux system like so. And we'll start off here. And this should be fairly simple. This demo will not be that complex. Now on your Kali Linux system, specifically for this lab as well as the other labs within the playlist, there's going to be an adversary emulation folder found within the home directory of the attacker user. And this contains a folder called labs and, the setup scripts. But, it's recommended to go through these and essentially work from, or set your working directory to the lab that you're currently working on just to organize things. So what I'll do here is I'll open up my terminal and I will just increase the font size so you guys can see this a little bit better. Probably smarter to open up, make this full screen. I don't know whether Firefox will allow me to refresh this. Let's go ahead and check this now, or to essentially extend. There we are. So there we go. So we have Kali up and running. So I'll now navigate into the adversary emulation folder. I'll just say labs and then lab 1.3. That's the one we're currently working in. All right. So now that we're within our working folder, I'm just going to open up MSF console. We don't really need the database. If you want to, you can. But yeah, so another thing to point out is that this particular lab, you know, if I'm just to exit full screen here, this specific lab actually covers all the techniques, you know, ranging from initial access all the way to AD enumeration. So do keep that in mind. We're just focusing on initial access first, and then you can go through the rest of the steps, but there's a couple of important stuff that I think you should wait for if you want to. But in any case, there we are. So in order to, you know, simulate the creation of our malicious attachment, we are going to leverage a fairly useful, although not that effective module, just, you know, so that we can establish initial access. We're going to utilize the word macro module. So I'm going to just search for word macro, something like this, and that's the one here. So exploit, it's an exploit module. So Office word macro, Microsoft Office word malicious macro execution. So I'll just say use, specify the ID of the module. I'm going to set the payload to Windows x64, so 64-bit interpreter payload. And then we are just going to reverse. Okay, we can use TCP like so. And now I'll just say show options. So the lhost is already set to the IP address of the Kali Linux system. We'll not change the exit function from thread, and that's actually a good thing, especially on modern versions of Windows. And you know, I think I can explain that now. So the exit function option in Metasploit, it's specifically relevant when you are configuring your payload, really Windows payloads, to be honest, although you might see them with Linux. But this option essentially allows you to specify how the payload will handle the process termination after the exploit is executed successfully. So it pretty much determines the mechanism that the payload will use to exit cleanly from the exploited process, right? And this is important because improper termination can crash the target application, right? You know, potentially alerting the user or defender. So in this case, because the target or the victim, who we're going to assume is running on the Windows system, you know, is going to open up a Word document. If we went for, let's say, the process option, what this does when you configure it as such is it terminates the entire process in which the exploit is running. So given that the macro will be executed by Word, or within the Word process, if you will, if we utilize the process exit function, then, you know, once it's done, it'll pretty much give us some interpreter session, but then it'll terminate Word, which is something we don't want, you know, both from a convenience perspective, but also from a general OPSEC perspective. You don't want the target to know that there's something iffy or something wrong with the document that they've just opened, right? The thread option is really, it's actually the recommended when, you know, targeting Windows applications, so something like Word, if you will. And it's very useful if you want the application that you're targeting to remain operational or exit gracefully without triggering alerts. So the way thread works is that it ends the thread that the payload is running in, leaving the rest of the application. So, you know, in this case, Word, Microsoft Word running, and does not terminate the entire process, only the specific thread spawned for the exploit. And then, of course, you have SEH, which I'll just explain really quickly. If you're not familiar with SEH, SEH stands for the structured exception handling. So this utilizes SEH. When you select that option, it utilizes SEH to gracefully terminate the exploited process. And it goes without saying that SEH is a Windows-specific mechanism that allows for handling exceptions or errors, if you will, during program execution. So in our case, we'll just go for thread. This module requires a file name if you want to. You can see it's going to utilize the docm extension, which is, you know, an alias for, or, you know, pretty much just tells you that this is a macro-enabled document. In the next video, I'll explain how you can, you know, utilize ActiveX and stuff to actually utilize the, well, I wouldn't say docx, but let's say a doc, for example. And you can specify a custom template, a docx template that is actually very useful. So if you have a custom docx template that's part of your phishing or your spear phishing attempt, you can actually specify the path to the file. In our case, we'll just go for the defaults, and we'll just hit exploit to generate it. So it's going to generate it using the default template that's under user share metasploit framework data exploits office word macro template.docx. And you can actually see there we are, it's saved under root msf4 local msf.docm. So I'm just going to copy the path to that file, and I'll open up a new tab, and I'll just navigate to Adversary Emulation, labs, and lab 1.3, just so that I'm working within the appropriate folder. It's not required, but organization is very, very useful. I'll then say sudo copy. Yeah, we don't really need to move it, given that this is not my Kali Linux system, so we can just copy it there. There we go. And now we have that running. Before we actually transfer it to the target system, or we sort of simulate a phishing attempt, which will essentially involve us somehow transferring the document to the Windows system, and then we're going to simulate the user opening the document. But yeah, so in order for us to actually receive the Meterpreter session, we're going to say we're going to utilize the exploit multi-handler. So exploit multi-handler, and we're going to set the payload to Windows x64 Meterpreter reverse TCP. And then for the options here, we're going to set the lhost to the Kali Linux IP, which will be the same for you, given that these IPs are static. And then we need to change the exit function to thread. This is very important. Otherwise, the word will pretty much terminate once the payload is executed. So we're going to say set exit function. Exit function. We're going to set that to thread, because that's what we had used when generating the document as well. And we'll just use lport, you know, the option we used when generating the document. And then now we can just hit exploit or run, and we have our handler running. So to transfer it to the target, I'm just going to set up a very simple web server with Python, the Python 3 module http.server. So I'm just going to say sudo python 3 module http.server port 8080, and we're going to host it. So now we can switch over into the Windows system. So I'll just open up that system via RDP. So we're now simulating, you know, the actual process of you know, the user downloading the document somehow, and then opening it up, right? So we'll just say put in the password there for the user madadmin. And again, I know this is not proper phishing or proper emulation, but this emulation plan was really designed to be more focused on the post-compromise phase, but I thought it would be a good idea to actually go through this. In any case, we can utilize PowerShell here. Of course, in a normal instances, the user would ideally, you know, download it or get it from an email. But in our case, we're sort of simulating this. I'll just navigate to the desktop. So we have, we can download it there, and then we can utilize PowerShell to say invoke. We can use web request. So invoke web request, and I'll just increase the font size here so that's clear for you guys, because I know sometimes this can be a little bit difficult to read. There we are. And then we just say URI, the IP address of the web server hosting the document, which in this case is going to be the Kali Linux system, so 192.168.123, and I believe we ran the web server on port 8080. The name of the file is just msf.docm, and then we'll specify the out file name as we'll save it under C users. The name of this user is madadmin, and desktop, and we'll just say msf.docm, like so. Hit enter. That looks like it's done. And again, now this is where we'll deviate from what's in the actual lab documentation, and we're not going to run Word as admin because no one ever does that. So we're just going to open up the document. Now, if you get an activation error, don't worry. That's not going to affect the lab or anything, or any, this particular demo. But we're going to give Word a couple of seconds to start up. It may take a minute. Who knows? Who knows with Word? All right. So, yeah, I'm just going to wait for this to open up. I don't want to skip through. There we go. Okay. So, users view only. The macro will still work. Next. Don't send optional data. Done. And there we are. So this is the template that Metasploit uses, or that module uses. So you can see fairly convincing that this document is essentially telling the user this document was created by a newer version of Microsoft Office and macros must be enabled. So let's go ahead and be or play the part of the stupid user. And for some reason, I don't know, this is very strange. There we are. So looks like it executed. So now, how do I exit? Oh yeah, I'm in full screen. So I'll go back into the Kali Linux system, the macro executed. You can see we get a GET request here on our, well, that was because we downloaded it, but here we have the interpreter session. So the stage is sent, and we have session 1. So first things first, let's learn a little bit about our system. We can see computer host name is target DC 64-bit. We also have a 64-bit interpreter session. Logged on users 13. That's very strange. I'm just going to migrate my process to Explorer. So I'm just going to search for the process ID for explorer.exe and then migrate to 4992, like so. And there we are. That should work without any issues. So there we are. Get user ID. You can see mad admin, and in this particular case now, if I say get privs to essentially view whether we are elevated, you can see we are not, because the privilege set that we have is again not indicative of us being an elevated user or a user with an elevated context. So we'll open up a shell session, command shell session. We'll say net user. So we can see there's an administrator, mad admin, which is who we are. There's also admin, KRB, TGT. But if I say, well, actually at this point, we would not need to do any crazy enumeration. We can just try and say, we can confirm the privilege set. So where am I? Priv, like so. So yeah, that's correct. If I now say net local group, just to check if this user is part of the local administrators group, local group administrators, we can see that mad admin is indeed part of this group. So while we are not elevated, we can leverage a technique like, bypassing UAC to elevate our privileges fairly easily. And that shouldn't take too much time at all. So in this particular case, if I just terminate this particular channel, and let me go ahead and if I put this in the background. So, for example, if I say load Kiwi, just to show you this, load Kiwi, and then we can just say creds all, just to show you that we're not elevated. So there we are, not running a system. I think I can also try and load incognito to see whether we have any tokens we can impersonate. So I can say list tokens. I'll just use the user tokens. So there we are. There's just the delegation tokens for the user mad admin. So we can't really do much on that front. In any case, what we can try and do now is just put this in the background. And we can search for bypass UAC. And the module that operates best for Windows Server is the silent cleanup module. If I can find it somewhere here, I believe this is the one here. So there we are. So we'll just say use 9, and we'll just say there we are. So we can actually set our payload to Windows. We might need to play around with this, but we'll just say Windows x64 interpreter reverse TCP show options. And in this case, do we need to change the exit? No, I don't think we do. So L port 5555. Let's just change it for organization. We want to set the session ID. So set session to 1. And the partial path. That's very important, but yeah, this is always a good module, because this path is always, or partial v1 is always going to be there. If I say show info, if you want to learn more about this, so there's a task in the Windows task scheduler called silent cleanup, which, while it's executed as users, automatically runs with elevated privileges. When it runs, it executes the file win directory or whatever that is called, system32 clean manager.exe. Since it runs as users and we can control the user's environment variables, the win variable here, or path if you will, normally pointing to C Windows, can be changed to point wherever we want, and it'll run as admin. So yeah, and we can set the sleep time, but it does actually perform cleanup, I believe. So in any case, we can try it out. Let's see if it actually works. So yeah, we are part of the administrators group, and it's going to send the stage. This is taking a bit more time, so we probably want to use different payload, or even an unstaged payload, because these can be quite tricky. And we're just going to wait and see whether we get anything. I doubt we'll get any prompt, because this is a silent technique, so we shouldn't get any UAC prompt here. What am I doing? No. Weird, always switching back. In any case, let me go back. I'm in an operating system within an operating system within an operating system. So multiple layers of abstraction. Anyway, I'm not sure this is working. It looks like we did get it. So yeah, that's port 5555. So let's try and see whether this worked. So get user ID. We should still be admin. However, if I now say get privs, we should have the elevated privilege set. So you can see pretty much everything you would expect here. And now if I say load Kiwi or something like this, and I say if I say creds all, there we go. Okay, so that's not an issue. That's primarily the interpreter session. So yeah, we can now impersonate NT authority, and that'll update the context from interpreter. So we can now say impersonate token, and again, if you're not familiar with this, it really is very, very simple. We just specify the name of the token we want to impersonate. So there we are. Now we say get user ID, there we are, and then I can now say creds all, like so, and that now works. And then yeah, so that's pretty much it. And now final thing in this video that I wanted to cover was of course the command and scripting interpreter. So as I mentioned earlier on in this video, the most common command and scripting interpreter that FIN6 has been known to use is PowerShell. Luckily for us, interpreter has an inbuilt PowerShell interpreter, so I can say load PowerShell, and then we can utilize PowerShell shell, and this is what we'll primarily be using. So this is much more stable than the command shell, which, as you know, can be quite tricky. But that is pretty much all that I wanted to cover in this video already. I think it's about 30 minutes, so I think it was a good idea. In any case, that's going to be it for this video. Now, in the next video, we're going to be, taking a look at how to generate your own macro-enabled document, how to craft or weaponize macro VBA macros. In essence, you'll be able to create your own Word document, macro-enabled Word document, that will give you a reverse shell. But the bottom line is you'll actually create the actual VBA code yourself. So that's the objective for the next video. And then after that, we'll resume with this lab, and we'll then move on to Active Directory enumeration and sort of staging the files or the information that we're gathering for exfiltration. So with that being said, that brings us to the end of this video. If you enjoyed this video, found value in it, leave a like, as it really does help in getting this video as well as other videos out to more people, and just improves its visibility in the algorithm, or helps boost the visibility of the video. If you have any questions or feedback, feel free to leave a comment down below. Furthermore, and this is very important, if you have any video ideas or topics that you'd like me to cover, please take a look at the content suggestions form in the description section. It's a very simple Google form that allows you to submit your suggestions, and it's based on that I'm actually going to cover, someone requested me to cover, the process of actually developing your own macros. So you can see that I'm going to take your feedback quite seriously. And then, the final thing I would just want to say is you can, if this is your first time, interacting with the CyberRangers platform, do take a look at the Adversary emulation playlist as well as the other free ones. There's another playlist that I developed on, Red Team Tradecraft. So, you can also check some of the previous videos. Anyway, thank you very, very much for watching, guys. And with that being said, I'll be seeing you guys in the next video.